Hello everyone, and welcome to everyone to this particular special talk on the World Environment Day. June 5th being the World Environment Day is being celebrated across the world, and of course we must have seen a lot of messages since morning about environmental protection, conservation, climate action, and a whole lot of other aspects of environmental governance and environmental security that is so important in today's world. As much as we are also battling with COVID-19 pandemic, we also have to remember that there are other crises which are quite looming and which are already affecting us in a big way. So in recent times, of course, with the cyclones that affected us, both Tokte and Yas, we have seen the kind of destruction that cyclones and other kind of environmental disruptions can cause to life and to ecosystems in a big way. To with us, guest Dr. Pushp Bajaj from National Maritime Foundation. It's a think tank that is based in New Delhi. And thank you so much for joining us on this occasion to give us a talk on a very important topic. Because very often when we talk about climate change, biodiversity, environment as such, oceans find very little focus. There's a lot more studies that have to be conducted to understand the ways in which environmental change interacts with oceans at multiple levels, and how climate change in particular poses various risks to maritime security, and a very important concept of blue economy, which is something that has become a buzzword even in India's maritime policies today. So oceans that way have, as far as I'm concerned, and in my own research, I have found that it is a much neglected subject in comparison to other topics, and therefore we need to also raise awareness about oceans and these issues much more. And I'm very happy to say that we have an expert to talk about this to our students and also the broader audience who has decided to join this webinar. Oceans are also part of the Sustainable Development Goals, and I don't have to reassert this point of how SDGs have become another buzzword. And since we are less than a decade away from achieving the goals of SDGs, and since one of the goal is oceans, SDG 14 actually talks about life below water, and it talks about conserving and sustainably using ocean, seas, and maritime resources for sustainable development. And another SDG goal that we are talking about is climate action, which is SDG 13. So in a sense, we are trying to address multiple issues that are related to SDGs, as well as maritime security and blue economy, which are all interrelated with each other. And these are highly critical to various disciplines. So it's not something that is just about environmental sciences, but we are studying international relations, wherein once again, the criticality of these elements to food security, economic security, livelihood security, and how oceans also regulate the global climate, all these issues becomes important to highlight. So without much ado, I would first like to invite Dr. Nandkishore, Associate Professor and Head of the Department of Geopolitics and International Relations, to give the welcome remarks. Over to you, sir.
Thank you, Dhanashree, and happy World Environment Day to everyone. This is a great occasion to join, though it's a Saturday, and then many of us we don't have classes or anything of that, so still a good number of students have joined, and also many of them have joined from outside, which is really a good thing. And pardon me with a bit of rains here. I think the range is a bit problematic. That's why I'm unable to use the video, because if I use the video, then immediately I think the quality drops down. That's what happened in the beginning. But nevertheless, I'm extremely happy to have Dr. Bajaj to deliver this lecture, probably perhaps better person to deal with the subject, and my congratulations to Dr. Dhanashree for found a resource person like Dr. Bajaj. Dr. Bajaj, the Department of Geopolitics and International Relations has been in existence since the late 90s, but subsequently in 2010, we started the master's program in Geopolitics and International Relations. So since then, we have been having collaborations with a lot of institutions. In fact, the institution that you belong to, we have sent a lot of students for internship, and then we have built over a period of time, we built a good relationship. And I'm really, really happy to take that relationship forward today with you delivering this very important, distinguished lecture and a special lecture for our department. So as we know, the subject is of greater importance. Not anymore we are debating about this phenomenon as either when I started teaching, there was still this debate of traditional security and non-traditional security. Still, people were trying to figure out where to fix it. From there, in less than a decade, the way the discipline has grown, and then subsequently it has come in the forefront. Now all hardcore think tanks as well have been concentrating on this one, and this has also been taken up by most of the important countries, major powers, as a very important initiative, and that's where we see a lot of progress that has happened. But at the same time, the situations are demanding greater understanding, which is required with more and more education. I think that's the only way we can have awareness in the society. More and more education, preparing people, trying to make them sensitive is very important. On the one hand, we always have the economic side of it with the blue economy and all those things, the maritime domain awareness, which India lacks or has been missing out. This is something that was spoken by even Panikkar the moment we got our independence. Since then, we've been speaking, but it has always remained in the backdrop. But subsequently, now at least we see that sort of leadership, and there is a lot more initiatives. A lot of them are researching. We see a whole lot of youngsters who are interested in climate, environment, maritime. All these are so intertwined, and I think you are the best person to deliver a lecture. I'm really happy to have you here. So on behalf of Manipal Academy of Higher Education, and specifically on behalf of Department of Geopolitics and International Relations, I heartily welcome you, and over to you. Thank you, Dhanashree.
Yeah. Thank you, sir, for that welcome remarks. And I think he has set the tone for the lecture. So before I invite Dr. Bajaj, I would like to give a brief introduction of him. Dr. Pushp Bajaj is a research fellow and the head of the Blue Economy and Climate Change Cluster at the National Maritime Foundation in New Delhi. His research areas of interest include climate change impacts on India's maritime and naval security, climate resilience of India's critical maritime infrastructure, sustainability in the maritime domain, and the blue economy. Prior to joining the foundation, Dr. Bajaj worked as an independent science writer and researcher focusing on climate change and the environment, where he published several articles on sustainable development, climate science, climate policy, and related areas. In fact, you will find a lot of his articles on Down to Earth magazine, the website itself. And he received his PhD in chemistry in 2018 from the University of California, San Diego, USA, where he was a graduate student researcher for the NSF-funded Center for Chemical Innovation, Center for Aerosol Impacts on Chemistry of the Environment, based in San Diego, USA. So thank you so much, Dr. Bajaj, once again for joining us. And now it's over to you.
Great, thank you. Thank you very much, Dhanashree, for the kind introduction, and also for inviting me to deliver a lecture on this very special occasion of the World Environment Day, and a very happy World Environment Day to all of you. If at any point, I hope that my internet holds out. If at any point you can't hear me, please do let me know and give a shout out. I'll start sharing my screen now. Dhanashree, could you just confirm that I'm in full screen mode of my presentation?
Sure, I'll do that, yeah. Yes, it's full screen now, yeah.
Okay, great. Thank you very much. And also thank you to the Department of Geopolitics and International Relations and the Center for Climate Studies at the Manipal Academy of Higher Education for giving me the opportunity to give this talk. The title of my presentation for today is Climate Risks to India's Holistic Maritime Security and the Blue Economy. To give you a brief overview of the presentation, during the presentation, I will try to address these three key questions. The first one being, why should we address climate change-induced risks to holistic maritime security? And the word holistic is key here. As Dr. Anand Kishore was saying, that there has been this one-sided focus towards traditional security threats in not too long ago, just a couple of decades ago, and now recently, in the recent few years, we have been seeing a shift towards a more holistic approach to maritime security, and that's what I would like to talk to you about. The second question is, the one question that everyone seems to ask, which is when should we address these risks? Or in other words, when would the impacts of climate change become significant and unavoidable? And then finally, the third question, how should we address these risks? Now, I'm sure that most of you, if not all of you in the audience, are already familiar with some of the basics of climate change and some of the more common impacts of climate change. So I will not spend too much time on that, but instead I would like to go more into the details and the nuances of how we should be thinking about climate change and how we should try to address this huge challenge. Now, starting with the question of why. Why should we address the security threats from climate change? I'm sure you would all agree that in recent times, climate change has evolved from a distant threat for future generations to a major imminent security threat for almost all nations around the world. And here I wanted to share with you some of the conclusions drawn from a global report published by the Center for Climate and Security in February last year. The report was titled A Security Threat Assessment of Global Climate Change. So here it shows the climate security threats in the near term, which is up to 1 to 2 degrees Celsius of global warming. And now at this point, I would like to remind you that we are already at about 1.1 degrees Celsius of global warming above pre-industrial levels. And that number changes slightly depending on how you define pre-industrial. So in the near term of 1 to 2 degrees Celsius of global warming, the report highlights that in the North American region, there is medium to, if you can follow my cursor, there is a medium to high level threat from extreme weather, drought and food stress, and regional migration. In South America, there is high to very high threat from water stress, regional migration, and fragile states. In the European region, there is medium to high threat from extreme heat, drought, and rising migration. In the African region, there is high to very high threat from food and water stress, loss of rural livelihoods, regional migration, and fragile states. And in the Indian Ocean region, specifically in South Asia and Southeast Asia, there is high to very high threat from rising seas, extreme precipitation, drought, and power tensions. And as we go further into the future to higher degrees of global warming, that is 2 to 4 plus degrees of global warming, we see that all of these threats, they evolve and they amplify from medium to high level threats to very high and catastrophic level threats. So talking about specifically India's maritime domain and the security threats in the maritime domain, the first, of course, the major threat is sea level rise. And there are some impacts of sea level rise, such as inundation of large swaths of coastal land, increasing frequency of tidal flooding, and saltwater intrusion into coastal soils and underground aquifers. And these impacts then have consequences for maritime security and the blue economy, such as economic losses from damage to property, which would lead to high insurance rates in coastal cities and coastal states, and heavy losses to coastal agriculture because of saltwater intrusion and also from increasing tidal flooding. These can leave heavy losses for coastal agriculture. Also migration, both internal, which is within India from one state to the other, from coastal regions to hinterland regions, and also from outside of India, from our maritime neighbors, for example, Bangladesh and Maldives, and so these, and also towards the west. There is also damage to critical coastal ecosystems such as mangroves from sea level rise, because they can to some extent manage the increasing salinity in the soil, but after a certain threshold, they also see the effects of sea level rise. And these impacts and consequences are very closely interlinked with each other, and often in very complicated and complex ways. The second most important threat to the maritime domain is increasing frequency and intensity of extreme weather events. As Dhanashri was saying in the beginning about the recent cyclonic storms that we have witnessed, both on the East Coast and also on the West Coast. So there are certain impacts of these intensifying extreme weather events, such as heavy damages. They lead to heavy damages in a short period of time. There is also increased vulnerability to health hazards in the aftermath of extreme weather events. There is in the ocean environment, there is ocean warming and deoxygenation, which are changing the fish distribution, the geographical fish distribution in the ocean. And there's also the threat of marine heat waves that can damage coral reefs. So because these impacts then have certain consequences for the maritime security and blue economy. As was mentioned earlier, the recent examples of the cyclones, which are now also occurring very frequently on the West Coast, which was previously not the case. But in the last 3 years, there have been 3 powerful cyclones on the West Coast. And the West Coast is not, unlike the East Coast, which has always experienced cyclones and high severity cyclones. The West Coast is not prepared for those threats because they have conventionally not experienced many cyclones. These events also, the damages from these events, the recovery period can take up to several months or even years. The fishery sector of the blue economy would have to adapt according to the changes that are occurring in the ocean environment. And also the loss of critical habitats, for example, the coral reefs and also the mangroves that I mentioned before. These will have an impact on the coastal tourism sector as well, because for coastal cities and coastal states, a major tourist attraction is the biodiversity and the ecosystems. So if there is any damage to those from climate change, that will have an impact, a negative impact on this very important sector of the blue economy. And again, these impacts and consequences are often interlinked with each other in complex ways. So, of course, in the time that I've been given, I cannot go into the details of all of these impacts. And the impacts that I talked about in the last 2 slides, they're only a small subset of the full range of impacts that we are expected to see in the future. So I will not go into any more detail of that. And instead, I will move on to the next question, the very critical question of when. When should we address these threats? Now, the answer to that ranges from yesterday to a couple of years or decades into the future. But it's a very complex question to answer. And in the next few slides, I would like to discuss with you why it is such a complex question to answer and why it depends on so many other factors that we are still discovering every year. So starting with the most important, the most critical threat to the maritime domain, which is sea level rise. This graph here is showing on the x-axis the year going from 1993 to 2020. And on the y-axis, it is showing the sea level height variation. So this is only showing from 1993 because that's when this is only showing satellite-based measurements, which began in 1993. But of course, there have been changes before 1993 as well. But nevertheless, in this graph, you see that the sea level has been continuously rising, and in fact, it is accelerating. Now, although this graph is only showing the global mean sea level, similar trends have been observed in the Indian Ocean. In fact, sea level rise in the North Indian Ocean is accelerating from 1.1 millimeters per year during the period of 1874 to 2004. It has moved up to 3.3 millimeters per year during the period of 1993 to 2017. And this is to say that contrary to common intuition, sea level does not and will not rise uniformly across the world's ocean basins. In fact, we know that in the Bay of Bengal, the Bay of Bengal region is experiencing much faster sea level rise than the global average. But of course, the more important question is how do we see this evolving into the future? And in order to understand what the climate might do in the future, we have to look at model-based future projections. So this slide here is showing model-based projections for sea level rise. And there are 3 panels, as you can see. The 3 panels correspond to 3 different scenarios. On the extreme left-hand side, you have the RCP 2.6, which corresponds to a scenario that is the most optimistic scenario, in which we assume that humanity takes urgent transformative action to mitigate our greenhouse gas emissions and to mitigate global warming. And on the extreme right-hand side, you see the RCP 8.5, which is the scenario in which we essentially do nothing to tackle the problem of climate change and we let it run its course. Now, it won't surprise you to when I say that we are closer to the RCP 8.5 than we are to the RCP 2.6 at the moment. But of course, there are new, more ambitious targets that are being set continuously, and also new efforts that are being undertaken. So there is, it's more likely that we will be somewhere in the middle of these two scenarios. But nonetheless, if we just look at the RCP 8.5 scenario, the projected global mean sea level rise by 2100 is expected to be around 0.84 meters, and with a likely range of 0.61 to 1.1 meters. And this is the conclusion of the latest 2019 special report by the UN IPCC on the ocean and the cryosphere in a changing climate. So I don't think I have to explain why a 1 meter sea level rise would have devastating impacts, not just for India, but all nations across the world. And specifically for India, our maritime neighbors. And if our maritime neighbors see the effects of sea level rise, that will of course have indirect effects on India as well. So this number of 0.84 meters is a very important number. A lot is riding on this number. So it's worth the while to spend some time and look at how we get to this number. Now, as I mentioned before, this number will dictate whether we should invest in long-term construction projects in the coastal regions of India. This number will determine the height of the seawall that we should build to protect our coastline. This number will determine whether we will have an influx of millions of migrants from Bangladesh or from Maldives or not, and when. And this number will determine whether the Maldives or the Lakshadweep will remain an island or they will turn into a rock. In other words, this number will determine India's and every other nation's long-term domestic and international policies. So I certainly would not want to be the person who determines this number. But as I mentioned before, that these are model-based projections. So if we look at if we try to understand the functioning of the global climate models, this here is showing a schematic representation of a global atmospheric model. Now, just before we started with the talk, we were talking about how the CCS is working on climate modeling. And so I'm sure that some of you in the audience might already be familiar with some of this. But essentially what happens in a climate model is you have a representation of the Earth, and that is divided into smaller grid points, and each grid is a three-dimensional grid, which includes the interaction between the air, the land, and the ocean. And so the grid size, when I say small, it's not really small. It could be as big as 100 kilometers by 100 kilometers, but because we are talking about the entire Earth, it is small enough. And so then each grid point includes, like it is showing here on the bottom left diagram, each grid point includes the interactions between the different elements of the atmosphere, the land, and the ocean. So if we look at the evolution of global climate models, the historical evolution, starting from the mid-1970s, when the first climate models were coming out, those models only included interactions between the sun, between the rain, which is to say the water cycle, and the greenhouse gas emissions. Then going into the mid-1980s, there was some more description of clouds. There was some more interactions with the land surface and the ice in the atmosphere, on the land. Then going to 1990, when the first assessment report of the IPCC came out, there were some more interactions included from the ocean. Then going to 1996, when the second assessment report came out, there was more description of volcanic activity and also sulfates. That is to say, there was more description of aerosols and also some more description of the ocean. Then going to 2001, when the third assessment report came out, there was some more description of the carbon cycle and the aerosols. And then in 2007, when the fourth assessment report came out, there was more description of the atmospheric chemistry. So clearly, the climate models have gone through a very interesting and a very remarkable transformation from the time when they started to now. And actually, this slide is only showing up to the year 2007, and more than a decade has passed since then. So there have been even more improvements in global climate models. But having said that, there are still inherent limitations in climate models and in the way that we describe the natural world, which we have to take into account. So the way that it works is that we have the chemical, physical, and biological relationships are transformed into mathematical equations that are then simulated in time, 100 years or so, to determine the future climate, to determine what the temperature would be like, what the sea level would be like, and what the water cycle would be like. But we simply do not know enough about the natural world to write every phenomena into an equation. Of course, there are ways to get around it, such as parameterization, but I will not talk about that here. We simply do not have enough data to feed into these models to improve their accuracy. There are many parts of the world that are, of course, inaccessible. And even those that are accessible, we are not doing enough to measure that data to feed into the models to improve their accuracy. We simply do not have enough computation power to simulate the entire natural world and all of its complexities with the accuracy that we require. So before I was talking about the grid size, which is of 100 kilometers to 100 kilometers. So if we want to go any smaller than that, we need a lot more computation power. And we do not have that at the moment, even with all the advancements that we have seen in the computational world, which has grown by leaps and bounds in recent decades, but it's still not enough to model the entire Earth with the accuracy that we need. So by design, climate model-based computer simulations will always be an approximation. Now, please understand that I am by no means saying that climate models are not useful. They're of course extremely useful. Without them, we would be blind. But the point here is that when we look at these projections, when we look at the future projections, we have to put them into the perspective of the inherent limitations, and we have to match them with observational trends to get a better idea. So, you will see in many policy-based documents and also in many discussions that the projections that are put out by the IPCC, they are considered like the word of God, or it's written in stone. But you see that every year we learn newer and newer things that make us rethink those projections and improve on them. And this idea is not understood by this, in my opinion, this idea is not understood by the circles that determine the policy and by the people that write about these policies. So that is the point that I'm trying to make. And if we go one step further and look into the causes of sea level rise, there are four main causes for sea level rise. There is the thermal expansion of the ocean. So as the temperature rises, the ocean water expands. There is also melting of the mountain glaciers. There is melting of the Greenland ice sheet and the melting of the Antarctic ice sheet. At the moment, the melting of the Greenland ice sheet is the single largest contributor to sea level rise, to global sea level rise. So if we look into that, if we look at the melting of the Greenland ice sheet, this slide here is, this slide is showing the surface melt area of the Greenland ice sheet going from the year 2000 on the top left to 2016 in the bottom right. So you can see that the area of the melt every year, it grows. So in 2002, we saw a large part of the Greenland ice sheet, the surface of the ice sheet was melting. Then in 2012, at one point, over 90% of the surface ice was melting. And more recently, in 2019, we saw similar levels of surface melting. So this is to say that the melting of the Greenland ice sheet is continuously accelerating. And there are multiple reasons for why that is happening. One of the reasons are these algal blooms that occur on the surface of the Greenland ice sheet. When we think of the polar regions, we think of them as these barren, devoid of all life kind of regions with very harsh climatic conditions. Now, all of that is true, but there is still life on these ice sheets. There is still microscopic life. So this image, for example, is showing algal blooms, all of this dark red, blackish kind of things that you see on the surface. They are algal blooms that were recorded during a science expedition. So what happens is when you have initial melting of the surface, that meltwater, in those meltwater ponds, there are conducive conditions, environmental conditions for these algal blooms to occur. And as they occur, they are dark in color and they cover the surface, which so the dark color helps them protect them from sunlight, but it's bad news for the ice because the dark color absorbs more sunlight and that leads to more melting, which creates more melt ponds, and those melt ponds can harbor more algal blooms. And so it enters into this self-reinforcing feedback cycle where the initial warming leads to algal blooms, and algal blooms lead to more warming, and that more warming leads to more algal blooms. So it enters into this vicious cycle. A similar phenomena is observed when we have wildfires in the Arctic. There are now increasing reports of wildfires in the Arctic. So this here is showing a satellite image of a 2019 wildfire that was in Canada's Northwest Territory. So the pollution that comes from these wildfires, the soot particles, they can travel hundreds of kilometers and they end up getting deposited on the surface of the Greenland ice sheet. Now again, since they are dark in color, they absorb more sunlight and that leads to more melting of the Greenland ice sheet. Now the only reason that I'm talking about these processes, these mechanisms that are accelerating the Greenland ice sheet melting is because none of these processes are incorporated in the global climate models that we talked about before. And the reason for that is that these are a phenomena that we are still discovering, that we have only recently discovered, and we do not know enough about them to transform them into equations which can then be accurately incorporated in global climate models. So the number that we saw before, the 0.84 meters of sea level rise by the year 2100, that number, we have to put that into the context of all of this new information that we keep getting every year. So moving on to the next big threat into the maritime domain, which is the increasing frequency and intensity of extreme weather events. Now, I'm sure that you have heard that statement many times that extreme weather events are becoming more intense and more frequent. But I think that this image here gives a very nice visual description of what that actually means. So if you see here, this is showing the distribution of temperature anomalies in the Northern Hemisphere for the months of June, July, August. The months do not matter, the region does not matter, because the profile of these temperatures is the same for most parts of the world. So it looks like a bell curve. If you look at the extreme left side, this 1951 to 1980 period, it looks like a bell curve where there is maximum distribution at the center, which corresponds to the mean value. So it is 0 because that's the mean value. And then on either side, you have on the hotter side, the probability decreases of hotter temperatures. And on the left side, the probability decreases of colder temperatures. So there is highest probability in the middle and then lower probabilities on the sides. So in this type of a setup, in this type of a distribution, the extreme events that we are talking about are these low probability events that occur very rarely and they correspond to very high temperatures. So they're called extreme events because the temperature is high, but also their probability is very low. Now, what is happening because of global warming is that this average, this 0 point is now shifting. So if you now look at the 1990 to 2000 period, the middle column, you see that the global average has shifted, and along with it, the entire distribution has shifted. So previously, what used to be extreme, very rare, very low probability events are now no longer low probability events. They have a decent probability of occurrence. And if we go even further to the last decade, that is the 2009 to 2019 period, the global average has shifted even more, and so the distribution has shifted even more. And now the extreme events that we previously considered extreme events are no longer extreme events. They're actually very much a part of the they're very much a part of the entire distribution. And what else is happening is that now there are these new extreme events which previously did not even exist in the distribution, but now they are showing up as the low probability events. So to sum up, the distribution of weather patterns is shifting. What used to be extreme low probability events are now becoming more common. And the extremes that previously did not even exist in the distribution are now showing up as the new extreme rare events. So what else happens because of changing temperature? We know that with every 1 degree rise in temperature, the atmospheric water vapor content increases by 7%. And more water vapor means more extreme rainfall. So this graph here on the x-axis is showing the year, and on the y-axis it's showing the frequency of severe flood events over India. And this was taken from a recent report published by the Ministry of Earth Sciences last year, and it shows that there is an increasing trend in the frequency of severe flood events over India. Of course, this includes all types of severe flood events, for example, from cyclones or from monsoonal flooding or tidal flooding, all types of flood events. Another conclusion that was derived from from this report was that the frequency of very severe cyclonic storms during the post-monsoon season has increased significantly, 1 event per decade during the period of, during the last 2 decades of 2000 to 2018. Another thing that happens as a result of these increasing temperatures. Now, I'm just sticking myself to the maritime domain. Of course, there are other events like droughts and land-based heat waves that also occur because of increasing temperature, but I will restrict myself to the maritime domain. So we are seeing that marine heat waves are also becoming more intense and more frequent. This graph here is showing the change in the heat content of the ocean from the year 1960 to around 2020. And we can see that there has been a relentless increase in the ocean heat content, which is a measure of the temperature of the ocean. And the oceans are actually absorbing nearly 90% of the excess heat that is generated from the greenhouse gases in the atmosphere. In the Indian Ocean, the sea surface temperature has increased by 1 degree Celsius during the period of 1951 to 2015. This is in fact much faster than the global average of 0.7 degrees Celsius in the same period. In fact, it's interesting to note that when I was talking about sea level rise, at the global level, Greenland, melting of the Greenland ice sheet is the major contributor. But for the Indian Ocean, the major contributor is the thermal expansion of the ocean. The temperature of the Indian Ocean is increasing much faster than the global average, and therefore it's contributing a lot more to the sea level rise in the Indian Ocean basin. It is also projected that many parts of the ocean will reach near permanent state of heat waves by the year 2100. Now, what that means is that previously what we used to consider heat wave states will now be so common that it will be a near permanent kind of a heat wave state by the year 2100. So now that I cannot go into any more details because of the time constraint, but now going forward to the question of to the third and final question of how do we address these threats. The first priority, of course, has to be the mitigation of future climate change, which must unequivocally take top priority to avoid some of the catastrophic worst case scenarios that I talked about during the presentation. And ironically, while climate change poses all these threats to our blue economy, pursuing a blue economy is in fact the ideal solution to mitigate climate change, ensure a sustainable future, decrease our dependence on energy imports, create new jobs, and enhance the technological progress. So ocean renewable energy resources, they offer promising alternatives to fossil fuels, and they could facilitate India's blue economy. Now, so far in India, the focus in terms of renewable energy has been on solar and wind. Now, of course, we need more and more solar and wind, but at some point, there are some limitations of land-based renewable energy resources for a country like India, which is already scarce with land resources. We will have to expand to more options and other alternatives. And in that sense, ocean renewable energy resources have so far been unexplored, and they offer a promising alternative to fossil fuels. Also, ocean-based carbon sequestration through natural ecosystems such as mangroves, seagrass, seaweed, and corals, they must be preserved and whenever possible enhanced. Mangroves, in fact, are much more efficient at absorbing carbon from the atmosphere than terrestrial forest systems. At the community level, we must promote awareness about the impacts of climate change, encourage community engagement, and reduce individual carbon footprints, while we also try to make more systemic changes in our economy to reduce the overall carbon footprint of the country. Now, while mitigation is important, there are some impacts of climate change that have already occurred and that are going to occur in the near future, no matter what we do. So we also have to adapt to those changes. We have to adapt to this new evolving climate. And in that sense, I found this quote, which I found to be very interesting, which says that climate change is not a one-time bump from one equilibrium to a warmer one, but rather a continuous accelerating process. This creates the need to plan not for a new static world, but for an increasingly dynamic one. So therefore, proactive adaptation is key. And we must boost the resilience of the critical infrastructure and support services to adapt to rising sea levels, frequent flooding, and cyclonic storms. And of course, these adaptation measures would have to consider region-specific needs and limitations. This would require independent risk assessment studies at the state level and the district level. Like I was talking about in the beginning of the presentation, that even if you just look at the east coast and west coast of India, they could have very different types of threats that they are facing, and also the local level social conditions, the economic conditions, and the technological conditions will determine the type of adaptation measures that can be incorporated. So all of that needs to be taken into account, and therefore we need these risk assessment studies at the state level and at the district level. And India must simultaneously brace for the eventuality of climate change-induced human migration of unparalleled proportions, both within India and also from our neighboring countries. Currently, we do not have the legal frameworks and the institutional capacity to deal with an influx of migrants. Forget about from outside India, even within India. We do not have a plan for the coastal populations that will have to move to hinterland areas as more and more of their land is inundated by sea level rise or by frequent flooding. So in this context, when it comes to climate change, there are certain things that are being explored by different countries in the world, and we also need to pay attention to those. The first method is, of course, to protect our coastline through creation of artificial barriers. And I mean, they don't necessarily have to be artificial. They can also be natural barriers. So they could be hard structures like embankments, seawalls, and tidal barriers, or they could be soft structures like nature-based infrastructure. For example, wetlands like mangroves and seagrass. They in fact act as very efficient breakers of tidal waves and also of sea level rise in general. And ecosystem-based adaptation, it also provides a cost-effective long-term risk reduction and other benefits to coastal communities. So there is that added advantage of the ecosystem services that they provide to the coastal communities. The second option is to accommodate or advance. accommodation means that you basically accommodate for the new sea level, the higher sea level, or you advance into the ocean by filling in the land with some sort of a material to raise the level of the ground. And this would have to be simultaneously accompanied with early warning systems and evacuation systems, hazard insurance, and new building codes and design standards to make the infrastructure climate resilient. Then the final option, of course, some places, some regions, we will either not have the capacity to adapt, or we will not, or the climatic changes will be so fast that we will not be able to adapt to those changes. So therefore, we would have to retreat in some cases. And this can either go horribly wrong, or it can go in a relatively peaceful manner, depending on how prepared we are for this type of a retreat. So it doesn't have to be just you leave your house and you leave. It has to be a very planned, very rigorously planned activity, which has to be undertaken by all levels of government and also the local communities. So this would include establishing setback zones. It would include relocating threatened infrastructure, upgrading the infrastructure located in risk areas, and also phasing out development in exposed areas or creating upland buffers. So in this context of adaptation, I would just like to highlight some of the ongoing endeavors of the National Maritime Foundation. We have a number of projects that are working in the area of climate change adaptation. We have a fellowship in place, which is the Vice Admiral K. Kinaiya Fellowship. This is for the period of 2020 to 2021, where we are looking at the climate risk assessment and resilience of coastal urban agglomerations. We were also recently awarded the 2021 Fellowship of the Coalition for Disaster Resilient Infrastructure, CDRI. This is for the period of 2021 to 2022, where we are looking at enhancing climate resilience of port infrastructure in India. There is also another active project, which is the quantification of climate change impacts on India's maritime and naval security. This is a long-term project which will likely stretch from the period of 2020 to 2022. Now, towards the end, I would also like to highlight our team at the National Maritime Foundation. We have NMF's senior management, Admiral Sunil Lamba, which is the chairman, Vice Admiral Pradeep Chauhan, who's the Director General. There is Captain Sarabjit Parmar, who's the Executive Director, and Commander Anand Kumar, who's the Deputy Director. Now we have recently established formally a Blue Economy and Climate Change cluster at the NMF. It currently comprises 4 researchers, myself, Mr. Saurabh Thakur, Ms. Chimi Udon, and Sarita Fernandez. I would strongly encourage you to visit our website and also check out some of our recent research on the subject of blue economy and climate change. We also have a number of international and national partners that we collaborate with frequently to organize dialogues and webinars, and also conduct a collaborative research on the subjects of blue economy and climate change. So there is the World Sustainable Development Forum in the USA. There is the Protect Our Planet movement in the USA, which is Protect Our Planet movement is actually conducting right now a 6-day event, which started today, I believe, on the occasion of World Environment Day, and it will go on till the 10th of June. And we are, the NMF is conducting a workshop on 7th of June on the subject of collapsing marine biodiversity and its implications for the blue economy. I would strongly encourage you to check out our social media, where we have links to the registration for the workshop. We also have our partners in Japan, the India-Japan Laboratory at Keio University. There is the Resilience, Innovation and Knowledge Academy at RICA, which is based in New Delhi. There is the Ocean Foundation in USA and the Institute of the National Polytechnic Institute in Mexico. With that, I would like to thank you very much for your attention. And this is my contact details in case you want to contact me after the presentation. Back to you, Tanushree.
Yeah. Thank you so much, Dr. Bajaj, for that wonderful talk. You touched upon so many issues, ranging from climate science to science policy interface to politics of climate science and politics of climate change to policy studies to science and technology studies. So you covered a whole range of disciplines. So it was truly an interdisciplinary talk itself, covering so many range of aspects pertaining to maritime security. And that's an important lesson for us and the students in particular, that when you do research on security related aspects, it is continuously being looked at differently, with an interdisciplinary knowledge being integrated into those understandings of security implications itself. So that was really very interesting talk, and I learned a lot from it actually. So thank you so much. So before I invite the audience to ask questions, I have Dr. Anish Warrior here, who is an associate professor at the Manipal Institute of Technology, and he's also the coordinator of Center for Climate Studies, to give a few remarks about the topic and also maybe reflect a bit on Dr. Bajaj's lecture itself. Yeah, Dr. Anish. And as Dr. Anish speaks, please raise your hand so that we can straight away start with the questions and comments from the audience. Thank you.
Hello, am I audible?
Yes.
Yeah, thank you, Dhanushree, and thank you, Dr. Bajaj, for a very wonderful and an enticing talk. You covered most of the topics that is relevant for today's special day. So at the outset, I want to wish everybody a happy Environment Day. And just in the afternoon, my wife was saying that we should celebrate Environment Day on all the 365 days and not only today. So as a researcher who is working on climate change myself, I just want to state that our planet is blessed with so many oceans, and we have got so many seas around us. And these water bodies are kind of, we can say that it is an elixir of life. They play a very important role in different aspects because the global economy thrives on a very healthy ocean, and it regulates the Earth's climate, as you have seen in Dr. Bajaj's presentation. Oceans can absorb more than 50 times of the carbon dioxide that is stored in the atmosphere. And as we pump in more carbon dioxide into the atmosphere, everything is getting absorbed by the oceans, and that leads to a serious issue that is called as ocean acidification, because the pH levels of the oceans are reducing. It is getting more and more acidic, and as a result of that, we have several microorganisms living in the oceans. They are slowly facing a severe threat. Apart from that, we also have very important minerals in the oceans like polymetallic nodules. We have ferromanganese crusts. We have metalliferous sediments, polymetallic volcanogenic massive sulfide deposits. So they are all a storehouse of very important metals, trace elements, and rare earth minerals. So what is going to happen in the next few decades is, once the land reserves of important minerals gets depleted because you are over exploiting these minerals, mankind is going to jump into the oceans to mine these minerals. And why these minerals are important? Because all the smartphone devices, the laptops, all the electronic devices that we have, they require certain amount of rare metals, rare earth elements, which are not found on the land, but they are found on the ocean bed. So watch out for this space, especially the marine minerals, in the next couple of decades. And other than that, the pollution threat to the ocean system is ever increasing. All the antibiotics, the pharmaceutical and personal care products that people use, then the improper disposal of the plastic waste, which will then get disintegrated into finer materials. So they are all called as microplastics and then nanoplastics. So what happens is, the fish living in the oceans, or the schools of fish, they consider these microplastics as food, and they ingest it, and then it leads to malnutrition and further lead to their death. Okay, so overall, as a responsible citizen, it is a need that we should preserve the oceans and see to it that we do not change the normal dynamics of the oceans. But from Dr. Bajaj's talk, we have seen that that particular dynamism of the oceans is consistently changing. And because the oceans are so important, the United Nations has rightly declared the current decade, that is from 2021 to 2030, as the decade of ocean science for sustainable development. So this is very important because the UN considers that the oceans are going to play a significant role in the next few decades, and we should take some important steps with the help of which we can safeguard the oceans. Okay? And on similar lines, the government of India has also launched a deep ocean mission with a total budget of around 4,000 crores for the next 5 years. So in this aspect, they are coming up with several scientific projects pertaining to the Indian Ocean, the Arabian Sea, the Bay of Bengal, and several themes have been outlaid. Okay? So overall, to end my talk, this brief talk, I would say that it is our duty that we should preserve the oceans, because as I said in the beginning, oceans are the elixir of life, and if the oceans behave differently, then we are the ultimate sufferers. For example, Arabian Sea never used to see so much of cyclones, but in the last few years, we are seeing an increasing trend of the cyclones because the Arabian Sea was considered to be a very calm ocean. When I was doing my PhD in the last decade, my PhD supervisor used to tell me that the Arabian Sea is very calm. It doesn't have many cyclones or tsunamis or any other natural disasters. But then recent studies have shown that the temperature, the sea surface temperature over the Arabian Sea has increased, or it is increasing gradually. And cyclones require this increased amount of ocean temperature. So they feed on this heat which is coming up from the oceans. So I think with this few words, I just want to wish everybody a happy environment year, not a day. And in 2 days' time, we are going to celebrate the Oceans Day, the World Oceans Day, on 8th of June. So probably this talk today by Dr. Bajaj is adds up to both the days, Environment Day and Ocean Day too. So I thank you all the participants for taking out your valuable time and attending this important talk. Also, thank you to Dr. Bajaj for sharing his thoughts on this particular topic with all of us. And that's it. Thank you once again.
Thank you so much, Dr. Anish, for those comments. And I'm happy that you also brought up additional points there about deep sea mining, fisheries, all these aspects, which are topics that are also intriguing international relations scholars, because there's a lot of competition that is happening between countries over who gets to mine the deep seas and get access and explore these resources also. And of course, we also have a lot of fisheries conflicts that are happening in the Indian Ocean region as well. So thank you for raising these issues. Now we move on to, as I mentioned, the Q&A session. So yeah, we have one question here. Others also, please raise your hand when you have made up your mind about what question to ask. So we have Dr. Anand, who's my colleague at the Department of Geopolitics and International Relations. So yeah, over to you, Anand.
Yeah, my question to Dr. Bajaj, before that, let me just congratulate you for putting the science behind climate change and its effect on the maritime environment in a very simple manner. Now, coming to the question, I wanted to know that since you have mentioned about the inadequacy of the scientific models towards explaining, all the possibilities which could give rise to climate change related effects. If that is the situation, then what do you think about certain factors which may give a negative feedback to the system in terms of, like, for example, one thing which have always puzzled me is about how the increase in carbon dioxide levels in the atmosphere actually will possibly create a much more better environment for the growth of plants, which might take over again a lot of carbon dioxide from the atmosphere. So, that kind of a situation where there can be some negative feedbacks. Have you come across such studies while doing your research? I just want to know about that. Thank you.
Right. Yes, sir. Thank you for your kind comments. And also, yeah, regarding this point about, of course, the natural world is a very complex, system. It's a very complex, interconnected system. So there are some things like you mentioned that with increased carbon in the atmosphere, it might support increased vegetation, and that is true. But then if you add, so scientists have discovered these phenomena and they've studied these phenomena and they've tried to put a number on it, like how much will it contribute to the future climate change and the future increase in global average temperature. So what has been found generally is that there are, first of all, more negative feedback loops than there are positive feedback loops. And so in this case, positive and negative have, they're kind of mixed up in this case. So by negative, we mean that things that would increase the temperature, and by positive, we mean that things that would decrease the temperature. Sorry, excuse me 1 second. It's the opposite. It's the opposite. So if you have a positive reinforcing feedback loop, that creates a positive feedback. So you have some temperature increase leading to a phenomena that further increases the temperature. And there are some feedbacks which some increase in temperature leads to a decrease in future temperature. So there are both of those. But what has been found is that there is more of the positive kind than there are of the negative kind. And that's what so the more we discover more and more of those type than the other type. And so when you put all of it together, then the result that we find is that ultimately the temperature will continue increasing at an accelerating pace.
Thank you, Dr. Bajaj.
Thanks.
Thank you. Are there any other questions? Sorry. Okay. So before, actually, I have a question that I wanted to put forth to you, especially that would be also good for the international relations scholars, IR scholars who study maritime security as part of the course itself, as a part of the program. For instance, like I mentioned about the fisheries conflicts, which are already sort of increasing in the Indian Ocean region. You find conflicts between Bangladesh and Myanmar, between India and Sri Lanka. And as you mentioned, and as Dr. Anish also mentioned, the biodiversity is one of the major, the marine species is one of the major part which is going to be affected by the rising temperatures, the sea temperatures itself. So in that sense, have you, as part of your studies at NMF also, are you looking into how these conflict dynamics can be influenced by fisheries? And I see a lot of studies are coming up on East China Sea, South China Sea, because of the already existing conflicts there between China and its neighbors. But similar kind of, similar kind of models, have you really come across anything in the Indian Ocean region?
Right. Yes, that's a very interesting question, because the marine species do not see the international boundaries, that the fictitious international boundaries that we have created in the ocean. And like I was saying in a part of my presentation, that because of the changing conditions, marine conditions, the fish species distribution are changing. Marine species are very sensitive to temperature change. So they can survive only in a very small window of temperature. So if the temperature goes beyond that, then they have to move to a different region, a colder region. So it is very much possible, and it has in fact been seen in history that fish species can cross exclusive economic zones, the boundaries of exclusive economic zones, and they can enter either from, let's say, India's EEZ to high seas, or from India's EEZ to our neighbors' EEZ. And in that case, that creates that could potentially lead to conflict. When it comes to fisheries, we have seen that there is active conflict in the Pak Bay, for example, between India and Sri Lanka, and also in the Gulf of Mannar. So if there's any change there, let's say in the distribution of fish species where they go from one EEZ to another, then that could certainly lead to conflict. And in order to address that, we need increased regional cooperation. So we do need the two countries or the region as a whole to make plans for such events, because they are going to happen. And in the past, we have seen that such movement of species have led to conflicts. For example, there was a mackerel war between when the mackerel species moved from Greenland waters to European waters, and there was conflict there. So they have been observed in the past, but the examples have been few and far in between. But now, with the accelerating changes in the ocean environment, those examples will become more common in the future.
Yeah, thank you. There's a question in the comments from a student, Aishwarya. She's from first year masters in our department. She has a question about actually oil spills, and I think that's also a very relevant question, because we have seen how the Mauritian case led to major. It was declared as an emergency in itself by the Mauritian government as well as by the rest of the countries. So she wanted to know what kind of impacts can instances like oil spill can have on zooplanktons, hydroplanktons, and do you think it would affect the ocean cycle, and then how would it then affect the blue economy also?
Yes, absolutely. I mean, absolutely, oil spills have, and they can travel very long distances. They can travel hundreds of kilometers, through the ocean currents. And I think the case that happened in Mauritius, it severely damaged the coral reefs in Mauritius and damaged the marine species. And the important question here is, what do you do after that happens? Or, I mean, first of all, we have to talk about what can you do to prevent that from happening. But once it happens, also we are not clear about the procedure that is being followed after that, and also who is held responsible for such an event. And when we talk about the pollution caused by ships, which is both in terms of like an oil spill, but also the air pollution, the emissions that are caused by ships, they're very difficult to classify and to categorize and to kind of assign responsibility to someone or the other, because of the international nature of the shipping industry, where you could have the ship bearing the flag of a different country, carrying the cargo of a different country, with a crew of a different country, and the flag nation being someone else altogether. So that type of an international setup, it makes it difficult to assign the responsibility of such an event or the pollution in general, and force them into making better choices, into following better pollution protocols. And so that is a challenge which is in the legal and the institutional framework. And at the NMF, we are very much interested in understanding these challenges. We have an entire division that works on public international maritime law. And one of the things that we study is this aspect of marine pollution and also air pollution that is caused by ships in the shipping industry.
Yeah, thank you. We have a question from Madhuvanti. You can unmute yourself. She's also a student at our department.
Good evening, sir. Thank you for the wonderful presentation. Sir, I have a doubt. Recently read an article between how global warming and the monsoons getting severe are related. Can you please be brief on that? And what impacts it would have?
Yes, certainly. So the monsoon itself is a very complex atmospheric phenomenon. And one of the things that it depends on is the temperature difference between the land and the ocean. So the ocean surface temperature and the land temperature. So what is happening because of climate change and because of global warming is that temperature difference between the land and the ocean is changing. And so when that temperature difference changes, and that temperature difference is also seasonal. So it would be different in the summer season than in the winter season. So when that temperature difference changes, it affects the monsoon wind patterns. And with the monsoon wind patterns, it affects the intensity of the rainfall and the duration of the rainfall. So some of the studies have shown that in the future, the monsoon patterns will become more erratic in the sense that they would become more unpredictable, and they would also become more extreme. So when it rains, it will pour down heavily, and when it doesn't rain, then it will be like drought-like conditions. It is also the most fundamental physical concept is that something that I also mentioned in my presentation, that when you increase the temperature of the atmosphere, its ability to store water vapor increases. So it can store more water vapor, which means two things. The first thing it means is that it can now, the evaporation increases. So it can take up, because of the heat, it takes up more water vapor from land, which means that the land becomes drier. So the drought conditions are amplified because of this increase in temperature. The second thing that happens is now, because the atmosphere can hold more water vapor, when it rains, it will rain very heavily. So it kind of works on both the extremes, that it causes more droughts and also more rainfall. So that is in general, that is the general physical concept. But the monsoon is more complex. Like I was saying, it depends on many different things. But the general scientific opinion is that in the future, monsoons will become more erratic and more extreme.
Yeah, thank you. So we have another question here from one of our students. Once again, first year master student, Gargi. She wants to know more about, this question, she says, pertains to the maritime domain awareness and India's naval strategies. So how can the Indian Navy, since you work with NMF, I'm sure you will have a lot to say about this. How can the Indian Navy take climate change induced risks into considerations, and what are the core areas that they should or can focus on in that respect?
Yes, that is a loaded question. So, there are two ways that I look at this. The first is Indian Navy's role in ensuring security of the country and of the maritime domain. So in that sense, the things that I talked about, the planning and the preparation for sea level rise, and the planning and the preparation for more extreme weather events, both of those would require the inputs from the Navy and the contributions from the Navy. So if there is going to be a retreat plan, let's say, for sea level rise, or if there's going to be any sort of an adaptation plan for sea level rise, that would require a lot of human resources, technological resources, and I'm sure the Indian Navy would have to play an important role in that. Similarly, when it comes to extreme weather events, Indian Navy is the primary responder in the Indian Ocean region for humanitarian assistance and disaster relief operations, not just for India, but also for India's maritime neighbors. So with increasing frequency of extreme weather events, they would have to increase their capacity of such HADR operations. They would have to be more responsive, they would have to be more prepared, and they would have to be prepared for larger scale events. So that's one aspect of it. The second aspect of it is that the Indian Navy itself is vulnerable to the impacts of climate change. Indian Navy's major naval bases, the armament storage depots, the hospitals, the civilian facilities, all of those facilities are mostly located along India's coastline and in the island territories. So the same threats that are facing the general population, the same threats are also facing the Indian Navy's establishments and the infrastructure and the personnel. So they have to adapt, for themselves as well to ensure proper functioning in the times of distress and long-term sustainability of the infrastructure. So both of those things are very crucial for the Indian Navy.
Are there any other questions? There's one more question, I think. Yes, this is from Kiran, another student from Geopolitics and International Relations, first year student. So his question is, we are seeing that in order to benefit from economies of scale, the ship size are seen to be growing continuously, but due to the increase, there is a lot of dredging activity to accommodate them. So how does this affect the coastal regions, especially the fishing activities, and are there any feasible alternatives?
Right, it certainly does affect the the coastal regions. Dredging is a problem for seagrass ecosystems, for example, which are found in the, in the shallow waters, and so those are uprooted by dredging, and also the marine life that depends on that will, of course, get displaced because of that. As far as, when it comes to alternatives, I do not have a very good answer off the top of my head, but the idea is to have. You're right that with the expansion of trade, of international trade demand, there is going to be an expansion of the shipping sector, and the problem is actually bigger than just dredging. The shipping industry contributes around 2 to 3% of global greenhouse gas emissions. If it were a country, the shipping industry, the international shipping industry, would be the 6th largest contributor of greenhouse gases. So if the trade keeps increasing, in fact, there was a projection by the International Maritime Organization which said that the greenhouse gas emissions from the shipping sector could increase from 50% to 250% by the middle of the century, by 2050. So there are significant challenges when it comes to the expansion of the shipping sector and how we can do that sustainably. And this is, in fact, a very important area of research interest of the NMF. And we will continue to work on this and provide better solutions and better recommendations for a sustainable shipping sector.
Okay, yeah, thank you so much, Dr. Bajaj, for answering those questions. If there are no questions, I will probably end by asking one last question from my side, and this has to do with a lot of Indian initiatives that have come up recently, like Sagarmala project, and so many different projects that Dr. Nankishore also mentioned in the beginning, that we are focusing a lot more on the maritime strategy now. So, in your opinion, has climate change and other environmental issues like biodiversity and other issues, have they been adequately integrated into these projects as far as trying to make them more sustainable? If not, how do you see the way ahead for the Indian establishment itself?
Right. Yes, that is a very important question. And the way I see it is that it's very fragmented. There are some sectors of the government, both at the national level and at state levels, that are paying attention to environmental challenges and trying to come up with solutions, whether it's related to marine conservation or to reducing the carbon footprint of the different economic sectors. But the challenge is that there is another sector of the government, there is another ministry which is doing everything that they can to expand this economy, to expand this sector, and to develop as much as they can. So there is this disconnect between these two authorities trying to do two different things. And so the way forward has to be an integration of, there has to be more communication between the different ministries. For example, this Sagarmala program. The Sagarmala program, I mean, now it's become the Maritime India Vision 2030, which has kind of superseded Sagarmala. So the Maritime India Vision 2030, it talks about development of ports, it talks about technological advancement of ports, but it does not talk about, as far as I know, it does not talk about climate change. It does not talk about the adaptation of the port sector, the resilience of the port sector towards the impacts of climate change. It does talk a little bit about sustainability by using better technology, but not nearly enough. But there are other, like the Ministry of Environment, Forests and Climate Change, and also the Ministry of Earth Sciences. They are taking initiatives to tackle the challenges of climate change, but there is no communication. So that siloization in the government, that is the problem. So that communication has to increase if going forward we want to have a more holistic approach to sustainability in the maritime domain.
Yes, yeah, I guess siloization is a perennial problem as far as governance is concerned, including that of the oceans and maritime governance. So I'll stop there, and I don't see any other hands up or no questions in the comments also. So thank you so much, Dr. Pushp Bajaj, once again for gracing us and also giving a wonderful lecture to our students, not only from Geopolitics and International Relations. There are also students from Geology and other departments of the university who have joined us, and I see that there are also a few guests from outside the university who have decided to join us on this occasion. So thank you so much once again. So I will officially now deliver the vote of thanks. So as I mentioned, thank you, Dr. Bajaj, and I hope to see you again. Give us lectures and also give us talk to us and discussing some of these issues at greater length with our students who are deeply interested. Many of them are working on maritime security related issues as well. So it would be very interesting for them to integrate these concerns more and more into their research, which tends to get neglected as you know, in international relations, how environment has always been a peripheral concern. So as I see, it is coming to the core now, and it's important for students of India who deal with it also to realize the importance of this issue. So thank you once again. I would also like to thank both Department of Geopolitics and International Relations and the Center for Climate Studies, Dr. Nandkishore and Dr. Anish Warrier, for helping us coordinate this particular program on the World Environment Day. It was done on a very short notice, in fact, so in that sense, I should also thank once again Dr. Bajaj for agreeing to give this talk. And I would also like to thank all my colleagues at the department for coordinating, for helping us coordinate the session in a better way. And I would like to thank the university. We have actually started focusing on SDGs, climate related research, also doing interdisciplinary research, which can promote more climate research in all departments. So that we have a better understanding of the ways in which climate change interacts with our lives, with politics, with science, with so many different disciplines, which require a much deeper understanding. So in that sense, the university has also given us that kind of space to do, to conduct such lectures and also help us advance research on these issues. And last but not the least, yes, I would like to thank our students for joining us and asking these really good questions and making the interaction very fruitful and beneficial for everyone. So yeah, thank you so much, and hope to see you again, and hope to see everyone else also in future interactions on themes like these. Thank you. Bye.
Thank you very much, Dhanashree, and thank you to all the participants and for all those very interesting questions. Thank you.
Yeah, thank you, Dr. Bajaj. Lecture, give us more lectures. Visit us whenever things permit, whenever all these things come to normalcy. Thank you, Dhanashree. Take care. Bye.
Absolutely.
Thank you. Thank you once again, Dr. Bajaj, and thank you, Dhanashree. Thank you, Nandakishore